Hello viewers. Welcome to the YouTube channel. In this video we will study Lecture 2 of Class 12 Chapter, Current Electricity, for Board, NEET, CET and JEE. If you have any doubts please comment or join the Telegram channel. Lecture 1, video link is given in description. And don't forget to subscribe the channel. Let's start. Electrical resistance. Electrical resistance is a measure of opposition to the flow of current in an electric circuit. According to Ohm's law, V is equal to Ri. Therefore, R is equal to V by I. Resistance of a conductor is the ratio of potential difference across its ends to the current flows through it. SI unit is volt per ampere or ohm. Note 1. 1 ohm is equal to 1 volt per ampere. Note 2. Factors on which the resistance of a conductor depends on. A. Resistance of a conductor is directly proportional to length of a conductor. That is, R directly proportional to L. B. Resistance of a conductor is inversely proportional to cross-sectional area of a conductor. That is, R inversely proportional to 1 by A. C. Nature of material of a conductor. D. Temperature of the conductor. That is, R directly proportional to T. Note 3. Resistance of a conductor is directly proportional to temperature of a conductor. Next, resistivity of a conductor. We have R is equal to rho L by A. If L is equal to 1 meter and A is equal to 1 meter square, then R is equal to rho, or rho is equal to R. Resistivity of a conductor is the resistance of conductor of length 1 meter and cross-sectional area 1 meter square. SI unit of resistivity is ohm meter. Next, expression for resistivity. We have sigma is equal to Ne square tau by M. But rho is equal to 1 by sigma. Therefore, rho is equal to M by Ne square tau, where rho is resistivity, specific resistance. M is mass of electron. E is charge of electron. N is number of free electron per unit volume. Tau is equal to relaxation time M and E are constant. N and tau varies. Factors on which resistivity depends. We know that rho is equal to M by Ne square tau, where M and E are constant. Therefore, 1. Resistivity inversely proportional to number of free electrons per unit volume. That is, rho is equal to 1 by N. 2. Resistivity inversely proportional to relaxation time, that is rho is equal to 1 by T. 3. Resistivity does not depend on dimension, length and area of a conductor but it depends on nature of material of conductor. 4. Resistivity of a conductor is directly proportional to temperature. Next, conductivity. The reciprocal of resistivity is called conductivity. Formula is conductivity is equal to 1 by resistivity. That is, sigma is equal to 1 by rho. SI unit is ohm per meter or Siemens per meter. Next, let's derive the relation between current density and conductivity of a conductor. Or show that J is equal to sigma E. Proof. Consider a cylindrical metal wire of length L and uniform cross-sectional area A. The conductor is connected to a battery as shown in figure. When a potential difference is applied across the ends of the conductor, an electric field E will be set up in the conductor. Due to this electric field, the electron drifts with a velocity Vd in direction to opposite to the direction of electric field. Therefore, we have I is equal to V by R. Mark as equation 1. But R is equal to rho L by A. So, equation 1 can be written as I is equal to V by rho L by A. On taking this A to numerator, we get I is equal to VA by rho L. Now take A from RHS to LHS, we get I by A is equal to V by rho L. But I by A is equal to J, that is current density. V by L is equal to E. And 1 by rho is equal to sigma, that is conductivity. Now substitute these values in equation 2, we get J is equal to sigma E. In vector form, vector J is equal to sigma, vector E. This equation gives relation between current density and conductivity of a conductor. Next, obtain an expression for current in terms of drift velocity. Or, show that I is equal to nAVd. Consider a cylindrical metal wire of length L and uniform cross-sectional area A. The conductor is connected to a battery as shown in figure. When a potential difference is applied across the ends of the conductor, an electric field E will be set up in the conductor. Due to this electric field, the electron drifts with a velocity Vd in direction to opposite to the direction of electric field. By definition, the current flowing through the conductor is I is equal to Q by T. Mark as equation 1. But Q is equal to Ne. Mark as equation 2. The number of electrons per unit volume is given by N is equal to number of free electrons by volume of the conductor. That is, N is equal to capital N by V. On equating, we get N is equal to small n into V. But we have V is equal to A into L. Substitute in above equation, we get N is equal to NaL. Mark as equation 3. Now substitute equation 3 in equation 2. We get Q is equal to NaLe. Mark as equation 4. Now substitute 4 in 1. That is, I is equal to NaLe by T. But L by T is equal to Vd. Finally we get I is equal to nAVde. This is expression for current in terms of drift velocity. Next, derive the expression for conductivity of a conductor in terms of relaxation time. Consider a cylindrical metal wire of length L and uniform cross-sectional area A. The conductor is connected to a battery as shown in figure. When a potential difference is applied across the ends of the conductor, an electric field E will be set up in the conductor. Due to this electric field, the electron drifts with a velocity Vd in direction to opposite to the direction of electric field. N is number of free electrons per unit volume. The number of free electrons for a given volume of a conductor is equal to N into volume is equal to NaL. Total charge passing through the conductor, Q is equal to NaLe. The time in which the charges pass through the conductor, T, is equal to L by Vd. Therefore, the current flowing through a conductor, I, is equal to Q by T. On substituting Q values, we get I is equal to nALE by T. But L by T is equal to Vd. Therefore, the above equation is written as I is equal to nEAVd. Mark as equation 1. Take A, this side. That is, I by A is equal to nEVd. But I by A is equal to J, that is current density. Therefore, we can written as J is equal to nEVd. But drift velocity, Vd. Vd is equal to E by m into τ. Now substitute in 2. We get J is equal to Ne into E by m into τ. Therefore, we can write as J is equal to Ne square τ by m into E. Therefore, we get J is equal to sigma E, where sigma is equal to Ne square τ by m. This is an expression for electrical conductivity. Next, expression for mobility of electron. We know that mobility is equal to drift velocity by electric field. That is, mu is equal to Vd by E. But Vd is equal to E τ by m. Therefore, mu is equal to E τ by m divided by E. Cancel capital E from numerator and denominator. We get mu is equal to E τ by m. This is the expression for mobility. In next lecture, we study from how to measure resistors. So don't forget to subscribe the channel for more.